Hello friends, in continuation with previous video, today we are going to solve one problem using friction circle method. Last time you have seen the theory. It's a graphical approach and it's used for homogeneous C5 soil. So here for an embankment, so for a finite slope of height is given 9 meter and the properties of the soil is given to you as C prime 20 kilopascal, phi prime 10 degree, and the unit weight gamma is given to you as 20 kilonewton per cubic meter. The slip circle passes through the two and meets the top embankment at 4 meter. So if you go for the solution of this problem using friction circle method, which is a graphical approach, how will you go for the solution of this problem? So first of all, you need to select the steps. Here, the slope angle is also given. The slope angle beta is given to you as 30 degree. So step 1, select one scale. Select the suitable scale. And draw the embankment. So let's have here 1 centimeter equal to 2 meter. So what is the height? Height is 9 meter. Therefore, the height, if you want to draw it on your paper, or you can make use of the graph paper, what you need to do is to take a point, any point A, and here at point A, just with the horizontal, the slope angle is given to you as 30 degree. So at an angle of 30 degree, you can draw the line. And the height of the embankment is given to you. The height of the slope is given to you as 9 meter. So wherever it becomes 9 meter, that means 1 centimeter equal to 2 meter. That means you should have h equal to here 9 meter means you have to draw the height equal to 9 divided by 2, that is 4.5 centimeter. So this height is going to be, with the horizontal, should be 4.5 centimeter. Automatically, it is going to be 9 meter. So this is the embankment. Now, it is given over here that the slip circle passes through the two. So it passes through the two. And meets the top of the embankment at 4 meter. So 4 meter means 1 centimeter equal to 2 meter, so 2 centimeter. So here is going to be 2 centimeter. That means it becomes 4 meter. So at 4 meter it meets. So AB becomes the slope and it is going to meet the embankment, top of the embankment at 4 meter. Now, the radius is given to you as 16 meter. 16 meter means 16 divided by 2, 8 centimeter. So 1 is to 8. Now, 1 is to 200, that is, it is going to be 16 divided by 2, that means 8 centimeter. So here you can make use of the compass and you can, from the compass, keeping one end at A, you can draw an arc. So let's have an arc over here, which is going to be 16 meter. And from C, you can, taking radius equal to 16 meter, you can draw the arc. So it cuts at this point and this point becomes the center of rotation, O. Then you join O to A and O to C. So this becomes the central angle. And measure the central angle. This becomes the radius. So step 2 is measure the central angle delta. So this angle delta, if you draw it and measure it, it is approximately 85 degrees. So you get delta equal to 85 degrees. So friends, this angle is known to you. Now, join A and C, let's say A, B, C, D, this is D. So, this is the arc of a circle. ADC is an arc of a circle. Now, you can join A to C. So, if you join A to C, this becomes length of the chord, LC. And you can measure length of the chord. Or you can calculate it also. The length of the chord will be 2r sine delta by 2. So, if you measure it, this particular this, you get it 21.6 meter. Because it's a graphical tool, graphical technique. On a graph paper, you can easily do it. So a straight line A to C, you can join it and that becomes the length of the chord. Now, you can easily calculate the arc length ADC. How much it will be? the arc length of this circle will be r into delta. Delta will be in radians. R is 16 meter and delta in radians will be pi by 180. 180 degree equal to pi radians. So delta degree will be pi by 180 into delta. And delta is already known to us as 85 degree. So friends, you can calculate it. So if you take your calculator and calculate it, you will be easily able to do it. So it is this is going to be 23.73. So friends, both length of the chord and length of the arc both are known to you in meter. So everything here we have been able to calculate. Now what next? How will you calculate W, the weight? So weight of this segment here complete, that you need to calculate it. And because you know now the center of rotation, you can draw a circle. So friction circle can be drawn. So friends, how to draw the friction circle, that you know it. What would be the radius of the friction circle? As we know, here this is the point of intersection. This is O. Now, the next step is to draw the friction circle. Having radius r equal to r sine phi. Now phi is given over here. So it becomes 16. So you can calculate it. 2.77. So the radius of the friction circle is 2.77 meter. Very simple. You can draw the circle by taking a scale. What is the scale here? 1 centimeter equal to 2 meter. So if you divide it by 2, you know in centimeter that what should be the radius of the friction circle. Taking that, it becomes here 1.38. So you can draw a friction circle. So this friction circle, the radius of this friction circle is going to be 2.77 meter. Now Let's calculate the length LA. That means where the cohesive force is going to act. So the mobilized cohesion, as you know, is going to be parallel to AC or length of the chord. So parallel to AC, the mobilized cohesion will take place. Before that, you can also calculate the weight of the uh, this particular complete um, slice, which is A, B, C, D, A. So calculate the weight of A, B, C, D, A. Let's say it is W. So how will you calculate this weight? First of all, find out the area. And once you know the area of this A, B, C, D, A multiplied by gamma, that is the unit weight, which is given as 20 kilonewton per cubic meter, that will give you the weight. So how will you get the area? Complete area. So area of A, B, C, D, A is quite simple. First of all, you consider the complete sector OADC. So area of OADC. Now from here, you just this triangle, you can remove it. So minus area of triangle OAC. Triangle OAC. So this much you are removing it. So what is left out is this plus area of ABC. ABC. So first of all, let us find out the area. It's quite simple. What will be the area of this sector? Complete circular this sector. It's quite simple. You can calculate it. How will you do it? You know that what is the area of the full circle? It is going to be pi r square divided by 360. So if the angle is 360-degree, the full circle area is pi r square. But here, the central angle delta is 85-degree. So you multiply by 85. So this gives you the complete area of OADC minus what is the area of triangle OAC. AC is known to you. Length of the chord you have already calculated as 21.6 meter. So length of the chord being known to you, if you can drop a perpendicular to AC, so drop a perpendicular 90-degree from here, friends, just drop a perpendicular on AC. If you drop a perpendicular, So this point becomes E, right? Then you can find out the area as half into base, that is AC, multiplied by OE, plus you will have to add triangle ABC so that you get the complete uh, area under ABCDA. So what will be this? It will be half into base. What is the base? Base is going to be AC. For triangle ABC, this is going to be the base AC. Now from point B, you drop a perpendicular on AC. Let's say this point is F. So multiplied by BF. This becomes the area. So friends, Earth is known to us. Now, OE can be measured. So measure now, because you are doing on a graph paper, measure OE and BF and convert it into meter. So OE comes to be 11.8 meter. Graphically, I have solved it, and complete solution graphically you can see over here. It is there, complete. So you can graphically do it on a piece of paper, or the best thing is take a graph paper, and BF is 1.6 meter. So friends, now you can easily find out the area. Therefore, area of ABCDA, let's say this area is A. So if you simplify, therefore, area A can be computed very easily. And then the area A is going to be is 79.67. Therefore, calculate the weight. Weight W. So calculate the weight of ABCDA as W. So therefore W is 1593.5 kilonewton. Now this weight, where it will act, it is going to act as 3.6 meter from the vertical line passing through O, the center of rotation. So this is the center of rotation. So from here, if you draw a vertical over here, friends, you can do it very easily. And so just drop a vertical, and from here at a distance x bar, which is given as 3.6 meter, you can measure it, the weight W is going to come into picture, which is 1593.5. So we are able to show the weight. Now, next is to calculate the location where the cohesive force is going to act. So you know the direction of the cohesive force. It is going to act parallel to length of the chord, that is AC. So as we know, next step, that C, the total cohesive force, acts parallel to AC, that is length of the chord, at a distance LA, which is LA equal to length of the arc divided by length of the chord multiplied by R. Now, already you know the length of the arc is 23.73 meter. So, this is known. Length of the chord is 21.6 meter. And when you multiply it by the radius, which is given in the problem as 16 meter, friends, you will be in a position to calculate the value of LA, that comes out to be 17.57 meter. So now the picture is quite clear, that you know the location of cohesive force and direction is also known to you. So where will it act? It will act, so the direction as it is shown, that the direction of the cohesive force is going to be like this. So there is AC. So my cohesion force is going to be parallel to AC. So this is AC. And parallel to this, the cohesive force, capital C, will act. And the distance from O, if you drop a perpendicular over here, this becomes LA. So LA you have already calculated. So friends, you know the direction of this. Now, you know this force, extend this direction of W. So you know that there is a force. Now you can draw a force polygon. So next step is to draw a force polygon. You require three forces. For drawing this, you require W, you require C, you require resultant intergranular force. Now, you know that intergranular force here, where it will pass through, that you know it. So, you have got W, if you extend it. Now, wherever it intersects, W is going to intersect. This point is called, say this point is called H. So W is going to intersect C at H. Now through H, you draw a tangent. So if you draw tangent, this line, the straight line that you draw it, must pass and must become tangent to this friction circle, and that is called the resultant force. So we can draw this. The resultant intergranular force like this, and this force is the resultant granular force. You may call this force as F. So another force, let's say this force is F. So you know the direction. This F is tangent to friction circle. Right? I've already explained this. So you are going to have now W, which you have already calculated as 1593.5 kilonewton. C direction is known, and this resultant intergranular force F, its direction is known. Magnitude we do not know. So if you draw a force polygon, by knowing the magnitude of W, you can proceed. Let's say we take a scale and draw the force polygon. So if we draw a force polygon, friends, first of all, you take a scale. Say 1 centimeter equal to 400 kilonewton. So this 1593.5, let's see, divided by 400, 3.98. So 1593.5 divided by 400 gives you the length which will represent this force W, both in magnitude and in direction. So I am going to draw 3.98 centimeter vertical line. So this is 3.98, and this shows the force W. Now, I know the direction of this force F. So, parallel to this, you can just move this, and parallel to this, you draw a line, because you know only direction of F. And you know this end, this is the beginning. So, from here, parallel to this, you know the direction of C. So, parallel to this, here you draw the line, you get A, B, C. So, this gives you the total cohesive force that is going to mobilize. So, this force polygon help us in finding the magnitude of this force F and this force C. So, C and F magnitude can be found it out. If you measure it, and I have done so, it comes out to be 200 kilonewton. So, that is the total force that I have got it. So, friends, it is very easy. You can just find out. And this force, resultant intergranular force, is 1560. So, all the forces are known to us. Now, if you want to find out the mobilized cohesion, you know that Cm multiplied by length of the chord is going to be capital C. Now, capital C is known to us 200. Therefore, the mobilized cohesion is 200 divided by length of the chord. So, this is 9.25 kilopascal. So, having got the value of mobilized cohesion, I can what I can do next? I can draw next step. I can find out the factor of safety with respect to cohesion, which is going to be C prime divided by C mobilized. Now, what is C prime is given in this problem is 20 kilopascal. And you have obtained by friction circle method the value of Cm as 9.25 kilopascal. So, 20 divided by 9.25 gives you a factor of safety 2.162. With respect to cohesion, when F phi is going to be 1. What is F phi? In my theoretical lecture, I have talked about what is F phi. F phi, what is this? This is going to be tan phi prime divided by tan phi mobilized. This is F phi. So, when it is 1, because at what is this? R sine phi, I have taken phi equal to 10 degree. and then drawn this circle. So whatever I have calculated, this one is when Fi is going to be unity. Let's say I want the factor of safety for a critical slip circle equal to 1.5. So if you want that the Fs value, the factor of safety with respect to a strength equal to Fi equal to 1.5. I want this. Therefore, the factor of safety is going to be here the tan phi m prime equal to tan phi, which is 10 degree, divided by f phi, which is 1.5. Therefore, you can calculate the angle. Tan inverse shift tan inverse tan 10 divided by 1.5. This 6.7 degree. So now you can take another trial circle of radius R1. So draw another friction circle whose radius R1 is going to be R sine phi. Therefore, this becomes 16 into sine 6.7, 1.86 meter. So this is R1. So draw another friction circle. This was 2.77. Now you are draw another friction circle of radius R1 equal to 1.86 meters. So you can draw it here. Another friction circle. Now its radius is going to be R1. And repeat the complete process. The direction of now R will change. This implies that direction of R will change. Therefore, direction of this magnitude of C will change, resulting change in mobilized cohesion. Therefore, Fc you calculate it as C prime divided by C mobilized must be equal to F5 if equal to Fs. So this is the complete solution, and this speaks in itself about the methodology of friction circle method. So once you solve a problem by taking a graph paper, you understand it completely. So it is more important to deal with the numerical aspect than to go through the theory, because here complete process we have done it. So friends, this is all about the friction circle method, and I hope each and every point, step by step, we have been able to highlight it and solve the problem in totality. Thank you very much.